Good morning, class. Today we are going to learn about the numericals of shallow foundation and plate load test. So, fifth numerical is coming here. Design a strip footing to carry a load of 750 kilonewton per meter at a depth of 1.6 meter in AC. In a C5 soil having a unit weight of 18 kilonewton per meter cube and shear strength parameters as C equals to 20 kilonewton per meter square and phi equals to 25 degree. Determine the width of footing using a factor of safety of 3 against shear failure. Use Tarzagi's equation. So I'll give you 2 minutes. Kindly take your answer, then we'll justify whether you have done it right or wrong. So 5 minutes for you. Kindly solve the question. Okay, so we are going to start the solution for first. Assume general shear failure. You can assume it, or if you know the phi value, if it is greater than 36 degree, then it is general shear failure, and if it is less than 28 degrees, then it is local shear failure. Since phi equals to 25 degree, it should be local shear failure, but here they have assumed as general shear failure. Since you have to determine the width of the footing, and when it comes to the width of the footing and depth of the footing is given to you, which is nearly about 1.5 to 1.8 meter, then you can go for general shear failure because phi rises. When the value comes, compaction takes place while calculating the depth and other factors, then your phi rises and therefore you can assume general shear failure. So the formula for strip footing is QF equals to CNC plus sigma NQ plus zero point 0.5 gamma B and gamma. So for phi equals to 25 degree, we have, as in previous class, I have shown you the table where Tarzagi's bearing factors are given for general and local shear failure. Then you have to take care that for general shear failure, phi equals to 25 degree. From table itself, you can take NC, NQ and N gamma values, which are coming to you as 25.2, 12.7 and 9.7. Next is also phi. We know that it is gamma into D. So gamma here is coming to you as 18. This is your 18 and depth is your 1.6. Substituting these values, we get QF equals to C is 20 into NC 25.2. You have to take here. I have substituted it wrong. Plus gamma. Sigma is gamma into D, which is 18 into 1.6 into NQ is 12.7 plus zero point 0.5 into 18 into B into N gamma is 9.7. So B is not known to us. We need to carry the width of the footing. So the value of QF is coming to you as 867.8 plus 87.3b. So this will be your first equation. Okay. Now to calculate the second equation and evaluate the values, you should know the factor of safety. So factor of safety is given to you as 3. If it is not given, then you will assume as 3. Okay, at footing level. So the intensity of pressure at factor of safety 3 at footing level equals to Qf equals to 3, equal to, substitute the value of Qf which we have calculated in equation 1, 867.8 plus 87.3b divided by 3 kilonewton per meter square. So this will be equation number 2. Now applied load intensity. As it is a stiff footing, we are calculating it per unit length. So you are going total load Q 750, which is given to you here, divided by the cross-sectional area B into L. So L is for unit length, so you are taking it as 1. So this will come as 750 upon B kilonewton per meter square. So this you have to substitute. So equating equation 750 upon B equals to 867.8 plus 87.3 B divided by 3. So we get here this equation, quadratic equation, and solving it in your calculators, you will get B equals to 2.134 meters. Alright, now sixth problem, determine the depth at which a circular footing of 2 meter diameter be founded to provide a factor of safety of 3. Uh, so if it has to carry a safe load of 1600 kilonewton, the foundation soil at C equals to 10 kilonewton per meter square. Phi, this is phi, equals to 30 degree. Okay, this is phi equals to 30 degree and unit weight 18 kilonewton per meter cube. Use Tarzagi's equation. Okay, so what will be your solution here? So firstly, write down what is phi given, or whatever given you kindly please write down here. So given here is phi equals to 30 degree. We have from Tarzagi's equation 30 degree here, so this will be your general shear failure. So from here itself you can say from table NC, NQ and gamma की value हमको लेनी है. Then Tarzagi's bearing capacity equation for circular footing. Since here it is mentioned circular footing, तो इसका formula क्या हो जाएगा? QNF net ultimate bearing capacity equals to 1.3 CNC plus gamma D. Sigma is equals to gamma D and Q minus 1. Since you have to calculate the diameter and we are assuming that the water table is below the depth of the footing, okay, so NQ minus 1 will come plus 0.3 gamma B and gamma is considered. Alright, next is when substituting all the values, you have to determine the depth of the footing. So D will be here also and D will be in the equation. Okay, so substituting all the values, you will get the equation in terms of D here. So this will be your equation number 1. Now you know that QS, okay, ultimate safe bearing capacity is given by QNS upon factor of safety plus gamma into D. So substituting all the values, QS equals to QNS जो हमारा आया है, पूरा सब कुछ करके substituting and calculating all the values, we are getting this equation, 232.12 plus 148D. So this will be your equation 1. Now you know that actual load intensity QA equals to 1600, which is given to you. 1600 kilonewton actual load is given to us, safe load, divided by pi by 4 into diameter square. Why pi by 4? Because it is circular footing. So pi by 4 d square, diameter is given to you as 2 meters. So this is coming to you as 509.3. And equating the first and second equation. So 232.12 plus 147 d equal to 509.3. Okay. So solving all the values, you will get d equals to 1.89. So you have to consider it on the higher side, 1.9 meter. So this is how we have done it. Okay. Now plate load test. So what is the plate load test? So there is one assembly here. So when you have one assembly here, what you are going to do? Okay. So very in simple manner, I will explain you this diagram. You have to draw it whenever asked in the examination, or whenever you go on the field of highways, flyovers. So you have to conduct this plate load test. This is an in situ test. So there is a steel plate. It may be circular, it may be square, or it may be rectangular, which is having the dimension from 30 centimeter to 75 centimeter. So minimum is 30 centimeter and maximum is 75 centimeter. So this is a steel plate. Uh, Hydraulic jack is attached here. Here again a wooden platform, again a jack, and again a wooden platform is there. Reaction beam is kept here and the loading is kept on this reaction beam. This is your ground level and this is your pit. Here the dial gauges are attached on the either side of your holes and the displacement with respect to the load is observed. So plate load test is a field test to determine the ultimate bearing capacity of the soil and probable settlement under a given loading. So whatever loading you are gradually increasing. So first there will be two dial gauges. Okay. So when there are two dial gauges here, so what is यहाँ पे दो dial gauges लगा देते हैं. So this will be your one dial gauge here. Okay. And another dial gauge will be here. And this is monitored. The hole is much more bigger, so one man can go inside. Manhole is made, and from that manhole, these dial gauges are measured. So for 2 minutes, 4 minutes, 6 minutes, 8, 16 minutes, 24 minutes, half an hour, 2 hours, 4 hours, 6 hours, 18 hours, 24 hours, 48 hours, 72 hours. So this is how the gradual increase in the loading is done. And whatever interval of time I have told you, this dial gauges will give you the reading of the plate settling down. Okay. So at one time it will come that dial will be constant. It won't give you the reading. So that will be the end of the test. Okay, the test essentially consists of loading a rigid plate at the foundation level and determine the settlement corresponding to the loading. The ultimate bearing capacity then takes as the load at which the plate starts sinking at a rapid rate. The bearing plate is square of minimum size 30 centimeter square and maximum is 75 centimeter square. The thickness of the plate should not be less than 25 mm. They have two methods, gravity loading platform method and another is reaction truss method. So calculation of the plate load test. Kindly read this. I'm taking the lecture. So the plate load test at the site conducts to determine the allowable bearing pressure. A pit of size 5 BP into 5 BP. BP is the diameter of the plate or size of the plate or width of the plate. Excavates to the depth equal to the depth of foundation to conduct a plate flow test at the site. The plate should make a steel with a size of 0.3 meters square and it should be 25 mm thick. Occasionally, circular plates are also used. Sometimes a large size plate of 0.6 meter square is also used. In the pit, a central hole excavates of size BP into BP. The depth of the central hole BP can obtain. A plate load test is a field test to determine the ultimate bearing capacity of the soil and probable settlement under a given loading. So the test from the following relation. dP is depth of the footing plate, dP is the width of the footing plate, dF is the foundation depth, dF is the width of the foundation, or BP, dP is dF upon bF into dF. So this is how you have to calculate. Now what is the procedure of the plate load test? A plate placed in the central hole and load applied by means of hydraulic jack for conducting the plate load test. The reaction to the jack is provided by means of load platform or a reaction beam. At first, a sitting load of 7 kilonewton per meter square apply which releases after some time. The load then apply in increments of 20% of the estimated safe load or 1/10 of the ultimate load. So what you can see that first you have to release 7 kilonewton per meter square and after that 20% of the estimated load or 1/10 of the load you have to increase. You have to gradually increase the load. Suddenly we don't apply the load in the plate load test because we have to calculate the settlement of the plate also with respect to the soil. So the settlement record at 1, 5, 10, 20, 40, 60 minutes and further after an interval of 1 hour for clayey anatomia. These hourly observations continue until the rate of settlement is less than 0.2 mm per hour. So this is the condition. First you have to follow these minutes, then 0.2 mm per hour you have to consider. The test conducts until failure or at least until the settlement of about 25 mm has occurred. If on your dial gauge of 25 mm it occurs, then you have to stop the test. Or before 25 mm if the test fails, then you have to stop the test. The load intensity settlement curve, also known as a load settlement curve for the plate QUP. QU is the ultimate load, P is for plate. The ultimate load denotes by the break on a load log plot between the settlements and the load intensity Q. When the break does not well defined, the ultimate load takes as that corresponding to the settlement of 1/5 of the plate width. Alright. On the natural plate, the ultimate load obtained from the intersection of the tangents drawn. This is so the plate load test load versus this is your load and this is your settlement. So load versus settlement curve is drawn. You will get one load curve here. Then you need to draw a tangent like this. Okay. So two tangents are drawn here from both the sides. One from upper side and another from lower side. So you will get this ultimate loading that is measured here, which is your QU, and if you horizontally do here, then it will give you the settlement in mm. Okay, so this is how you have to draw. So next is test result of plate load test. The test result can be used as explained below. The ultimate bearing capacity of the proposed foundation QUF can obtain by using the following relations. For clay soils, QUF equals to QUP. For sandy soils, QUF equals to QUP upon into BP. To determine the settlement for a given intensity of loading, QU, this is QU, the plate can be used. The relations between the settlement of the plate SP and that of the foundation SF for same load intensity is given below. So for sandy soil, SF equals to SP into BF upon BP. To determine the settlement of the given intensity of loading QO, formula for sandy soil, SCS, this is important formula for solving the numerical. SF equals to SP BF BP plus zero point 0.3 upon BP BF plus zero point 0.3 raised to square. So BF is the width of the foundation in meter and BP is the width of the plate in meter. 0.3 cents. The minimum dimension is 30 centimeters square. The trial and error procedure adapted for designing a shallow foundation for an allowable settlement of SF. First of all, assuming the value of BF and the value of Q computed as Q0 equals to Q upon AF, area of foundation or footing, where Q is the load and AF is the area of footing. For the calculated value of QO, the plate settlement SP determined from the load intensity settlement curve obtained from the plate load test. Okay. By using equation 4 and 5. 4 and 5 matlab earlier equation and this equation, the value of SF can be calculated when the soil is clay and sandy respectively. The calculated value of SF compared with the allowable settlement. The procedure repeats until the computed value and equal to the allowable settlement. For determining the influence factor F, the plate load test also using from the given equation. S equals to 1 minus mu square upon ES into 1 into Q into B, where mu is the Poisson's ratio, E is modulus of elasticity of soil, I is the influence factor, Q is uniformly distributed load, characteristic length of the loaded area, a plot between the settlement and load QB show, the slope of the line is equal. Now here, what are the limitations of the plate load test? One is your size effect, second scale effect, time effect, interpretation of failure load, reaction load, water table, size effect of a plate load test. So the size of effect of the plate load test, the strength and the settlement characteristics of the soil within the pressure bulge reflected the results of the plate load test. So, as the pressure bulge depends upon the size of the loaded area, it is much deeper for the actual foundation. When the soil is not homogeneous and isotropic to a large depth, the plate load test does not truly represent the actual condition. So these are your pressure bulbs, this is your plate and this is your footing. So this would be maintained within the area. So this is known as your size difference. If the load is there and plate is there, the footing size will increase. Scale effect. For saturated clays, the ultimate bearing capacity is independent of the size of the plate, but the cohesionless soils, the ultimate bearing capacity increases with the size of the plate. To decrease the scale effect, it is desirable to repeat the plate load test with plates of 2 or 3 different sizes and extrapolate the bearing capacity for the actual foundation and take the average of the values produced. So time effect. Essentially, a plate load test is a test of short duration. It does not give the ultimate settlement for plate soil. The load settlement curve is not a purely representative. Next is interpretation of failure load. Except in case of general shear failure, the failure load does not well defined. In other types of failure, an error of personal interpretation may involve reaction load to provide a reaction of more than 250 kilonewton is not practicable. Hence, it is difficult to test on a large size plate of more than 0.6 meter width. Water table, the bearing capacity of the sandy soils affected by the level of the water table. When the water table is above the level of the footing, it has to lower by pumping before placing the plate. At the water table, the test should be performed when it is within about 1 meter below the footing. Advantages of the platelet test: bearing able to understand the foundation behavior under loading conditions, evaluations of bearing capacity of the soil at a certain depth and prediction of settlement for a certain load. Shallow foundation can be calculated considering the allowable bearing capacity, which can be predicted from the platelet test. Time and cost effective, easy to perform. So, numerical on the plate load test: a 30 centimeter square bearing plate settles by 8 mm in the plate load test on a cohesionless soil. When the intensity of the loading is 180 kilonewton per meter square, estimate the settlement of a shallow foundation of 1.6 meters square under the same intensity of the loading. So, what will be the solution? Density with respect to foundation, density with respect to plate, which is given by Bp plus zero point 0.3 divided by Bp up into B plus zero point 0.3 raised to the power square. So 8, B is given to you. Okay. How much it settles? 8 mm. Point 0.3 upon Bp again, which is given to you as 0.3, and 1.6 is B plus zero point 0.3 is to square, which is given to you as 22.7 mm. So the settlement is 22.7 mm. Next is your plate load tests were conducted in a C5 soil on plates of two different sizes, and the following results were obtained. Load 40 kilonewton, 100 kilonewton, size of the plate 0.3 into 0.3 meter, zero point 0.6 meter into 0.6 meter, settlement 25 mm. Find the size of square footing to carry a load of 800 kilonewton at the same specified settlement of 25 mm. Solution: for C5 soil, we have Hussels equation, Q equals to A into Q plus P into S. Q is total load on the bearing area, area of the plate, perimeter of the footing, bearing pressure beneath the footing, perimeter shear. In the above equation, Q and S are the two unknown. From the first test, we have 40. This is our equation we need to take care of. Q equals to AQ plus PS. Okay. So 40 is your loading area, zero point 0.3 into 0.3 into Q plus 4, perimeter is 4 into 0.3 into S. So this is your first equation. From second test, 100 is the load, size is 0.6 into 0.6, Q plus 4 again is the perimeter into 0.6 S. This is your second equation. Solving 1 and 2, you get Q and S this much. Okay. So the size of the square footing, 800 loading is given to you. Square footing, it will be B into B into Q plus perimeter 4B into 225S. So this will be a quadratic equation. From here you are getting the size of the footing as 2.2 meter. So this type of numericals we have already done in the previous classes. Uh, so this was regarding the plate load test and limitations, advantages of plate load test. If you have any queries, you can ask me anytime. So this was all for today. Any questions, you can give in the chat box. Okay, no questions. So we'll end over here today.